Hello everyone, in this video we are going to discuss about operational amplifier, also called as op-amp. Generally op-amp is a three-terminal device. It has three terminals. The first terminal is the inverting input terminals. Two terminals corresponds to the input and one terminal corresponds to the output. The first terminal is inverting input, the second terminal is non-inverting input, and the third terminal is the output terminal from which the output is obtained from operational amplifier. The output of operational amplifier is nothing but the multiplication of the amplification factor A and the input of the operational amplifier. Multiplication factor A and the input of the operational amplifier. The output signal is the amplification factor known as operational amplifier's gain multiplied by the value of the input signal. The input signal is multiplied with the amplifier's gain, which is called as A. The amplifier's gain is also called as amplification factor. It is denoted by the letter A. There are four different types of operational amplifier based on the input and output. If the input and output both are voltage, then the operational amplifier is of voltage operational amplifier. If both the input and output are current, then it is current operational amplifier. If the input is voltage and the output is current, if the input of the operational amplifier is voltage and the output of the operational amplifier is current, then the operational amplifier op amp is called as transconductance op amp. In case of input is current and the output is voltage, if input is current and output is voltage, then the op amp is called as trans resistance operational amplifier. Trans resistance when input is current and output is voltage. Trans conductance when input is voltage and output is current. So these are the four types of operational amplifier. This is the equivalent circuit of the symbol of operational amplifier. This one is the inverting input denoted by the negative sign. This negative sign denotes that this terminal is inverting input terminal. This positive sign denotes that this terminal is the non-inverting input terminal. Then this is the positive voltage supply and this is the negative voltage supply. These two bias are applied for the op amp. The resistance between these two input terminal is called as input impedance. This is denoted by Zin. This is called as input impedance Zin. The impedance at the output terminal is called as Zout, output impedance, and the output is obtained from the output terminal. The ideal op amp characteristics are: the ideal op amp has infinite open loop gain. The open loop gain of the ideal op amp is infinite. The input impedance Zin is infinite for the ideal op amp, whereas the output impedance Zout is 0 for the ideal op amp. The output impedance is 0 and the input impedance is infinity for the ideal op amp. The bandwidth over which the ideal op amp could operate is infinite. Infinite bandwidth for an ideal op amp, and offset voltage is 0 for an ideal op amp, which means if the input voltages are 0, then the output will also be 0. This is called as offset voltage. If there is no difference between the inverting input and the non-inverting input signal, if there is no difference between the inverting and the non-inverting signal of op amp, then the output will be 0. Then the output will be 0. This is called as offset voltage. It is 0 for an ideal op amp, but for a non-ideal op amp, the offset voltage will not be 0. These are the important ideal characteristics for an operational amplifier. This is the pin diagram for an operational amplifier. It has 8 pins. This notch is used to find the first pin. If the connection is given to the wrong pin, then this IC will be burned out and it could not be used for further applications. So this notch is used for finding the first pin of any ICs. The pin which is to the left of this notch, when the notch has to face the north direction, and the pin to the left of this notch is the first pin, followed by second, third, fourth, and the fifth pin is parallel to the fourth pin, fifth, sixth, and seventh and eighth pin. The first pin is the input offset, and the fifth pin is the input offset. For op amp, the first and fifth pin are same. The first pin is for input offset, and the fifth pin is also for input offset. The second pin is for inverting input. The third pin is for non-inverting input. The second pin is for inverting, and the third pin is for non-inverting input. Fourth pin is for supply. Fourth pin is for minus supply, minus bias, and the seventh pin is for positive bias. Fourth pin is for minus VCC, and seventh pin is for plus VCC. Sixth pin is to take the output from the operational amplifier. Sixth pin is for output, and for the eighth pin there is no connection. NC denotes no connection. There is no connection in the eighth pin. Second pin is for inverting input, third pin is for non-inverting input, and the sixth pin is for output. This is the pin diagram for operational amplifier. This mu A741 is the IC number for operational amplifier. Mu A741 is the IC number for operational amplifier. This is the first configuration, inverting operational amplifier configuration. This is the first configuration, inverting operational amplifier configuration, which means the input signal is given at the inverting terminal of the operational amplifier. The input signal, in this case, the input is of current and the output is also current. So it is a current operational amplifier. The input is current I in, given through the input resistance R in, given through the input resistance R in, and the feedback resistance RF is used. Feedback is nothing but part of output is fed back as input. The part of output current I0 is taken out and it is fed back as the input for the operational amplifier. This point X denotes that the potential at this point is equal to the potential at the non-inverting terminal input. This potential, the potential difference at the point X is equal to the potential at the non-inverting terminal input. This is called as virtual earth summing point, also called virtual earth. This is called as virtual earth. Is at the same, the X is at the same potential as the positive input. X is at the same potential as the positive input. In this case, at positive input, the voltage applied is 0. So the potential at X is also 0. Potential at X is also 0 in this case. The gain of this operational amplifier is nothing but minus feedback resistance divided by input resistance, minus RF by Rin. Gain of the inverting operational amplifier is minus of feedback resistance by input resistance, minus RF by Rin. Gain is nothing but output voltage by input voltage. In this case, output current by input current. So the output is equal to minus of RF by Rin into Vin. The negative sign indicates that there is the inversion between the output and the input. The negative sign in the equation indicates an inversion of output signal. There is a phase shift of 180 degree between the output and input. This is denoted by this negative sign, minus of RF by Rin into Vin. In case of inverting operational amplifier, there is a phase shift of 180 degree between the output and the input signal applied. This is inverting operational amplifier. Next one is non-inverting operational amplifier. In this case, the input is applied across the non-inverting terminal. This plus sign denotes the non-inverting terminal of an operational amplifier. The input is applied across this terminal, and the feedback resistance RF is used in the inverting terminal. For this, R2 is used as the bias resistance. The Gain for this operational amplifier in non-inverting mode is AV equal to 1 plus RF feedback resistance divided by the bias resistance R2. AV equal to 1 plus RF by R2. This is the gain for the non-inverting operational amplifier configuration. This non-inverting amplifier configuration, there's no phase shift between the output and the input. The output and input are in same phase. So this non-inverting operational amplifier could also be used as the buffer, which is nothing but voltage follower. In this case, this could also be used when the input is current and the output also current. For simplicity, we are taking input as voltage and output as voltage. Since voltage is given as input and voltage is taken as output, it is called as voltage follower. This is also called as buffer. For buffer, the gain has to be 1. For a buffer, the gain has to be 1. Here there is no R2 and RF, so this term gets cancelled and the value of the gain is equal to 1, which is nothing but V out is equal to V in. This is the buffer. If we take this non-inverting operational amplifier, in this case there is no feedback resistance RF and there is no feedback resistance R2. Bias resistance R2, sorry, there is no feedback resistance RF and there is no bias resistance R2, so this term gets cancelled and only 1 will be available, which means the gain of this non-inverting operational amplifier is 1, which means the output is equal to the input. This is the circuit for the voltage follower, also called as buffer, for using non-inverting operational amplifier. This is buffer using non-inverting operational amplifier. Next one is summing amplifier. This is equivalent to summer using adder using operational amplifier. The input voltages V1, V2 and V3 are applied across the inverting terminal, so there will be a phase shift between the output and the input. The first input V1, V2, V3 are supplied through this resistance, input resistance Rn. All the three resistance have the same value Rin and the feedback resistance Rf. So the gain of this operational amplifier is minus Rf by Rn. Minus Rf by Rn. Gain equal to minus Rf by Rn. If we give a gain equal to voltage output by voltage input. Voltage output is kept at the left side and the voltage input is given at the is cross multiplied to the right side. Here there is not a single voltage, there are three voltages. So V1 plus V2 plus V3. V1 plus V2 plus V3. This minus sign indicates that there is a phase shift between the output and input. Generally this minus sign has to be placed here, but there is no difference if you place minus here or here. V out equal to gain minus Rf by Rn. This equation is applicable only when all the three resistance are of same value Rin. So the gain is Rf by Rn into the input voltage, which is nothing but V1 plus V2 plus V3. This is all about summing amplifier circuit. Thank you.